module, we will look at the hydraulic system. First, we will start out with a system description. After that, we will look at the controls and indicators associated with the hydraulic system. The aircraft has two hydraulic systems. They are designated the blue and green hydraulic systems. The hydraulic systems are independent from each other and operate simultaneously during normal operations. The main components of the hydraulic system are located in the left landing gear fairing, aft of the main tires. These components include the pumps, accumulators, connectors and the main reservoir. Unlike other aircraft, the two hydraulic systems have a crossfeed valve that enables one system to pressurize the other system's components. Each hydraulic system is pressurized by an AC wild-powered electric hydraulic pump. Each pump delivers hydraulic pressure at 3,000 psi. The blue pump is powered by AC Wild Bus 1, and the green pump is powered by AC Wild Bus 2. The blue system has an additional auxiliary DC-powered pump that can be used to pressurize the blue system components when the aircraft is on the ground with no power. Even though you can cross-feed the two hydraulic systems, you should not cross-feed when the auxiliary pump is being used. Although the auxiliary pump operates like the other pumps at 3,000 psi, it is a smaller pump and it only produces about a third of the output. This pump runs automatically when the blue system pressure drops below 1,500 psi, the propeller brake is released, the gear handle is down, and at least one engine is running. The blue hydraulic system supplies hydraulic pressure to the nose wheel steering system, the flaps, the spoilers, and the propeller brake for the right engine. In addition, the blue system supplies the emergency and parking brake system. The blue system distribution is depicted on the AC Wild hydraulic page on the multi-function display, or MFD. The green hydraulic system supplies the landing gear system and the normal brakes. The green system distribution is also depicted on the AC Wild hydraulic page on the MFD. The two hydraulic systems use a common hydraulic tank that is located in the hydraulic bay. This bay is in the left landing gear fairing. The tank is a direct air fluid contact tank that is not pressurized. A baffle prevents splashing of the fluid and limits foaming. The total capacity of the hydraulic reservoir is 9.6 liters. A sight gauge is used to determine the quantity of the fluid in the reservoir. When the reservoir is full, the fluid level will be even with the upper mark of the sight gauge. A full indication means that there is a total fluid quantity of 9.6 liters. The lowest line on the sight glass is labeled refill. This line indicates the minimum quantity of hydraulic fluid required. When the reservoir fluid level is even with this refill line, there is a quantity of 8.5 liters. The aircraft has sufficient hydraulic fluid for flight, as long as the hydraulic fluid quantity is above the refill line. When the hydraulic reservoir is filled, hydraulic fluid is added until the fluid level reaches the normal filling level. When the fluid level is even with this line, the hydraulic reservoir contains 9.35 liters. Hydraulic fluid is added to the tank through the filler cap. Skydrol is the most common brand of fluid used. Approved fluids are Skydrol LD4 and Hyjet 4. The hydraulic tank is divided into two compartments that supply the blue and green hydraulic systems. Each compartment has a fluid capacity of 4 liters. The top of the tank divider is below the minimum filling level. If a leak develops in one of the hydraulic systems, the fluid quantity in the reservoir will decrease below the level of the compartment divider. At that point, the fluid in the compartment that services the system with the leak will continue to decrease until there is no more fluid remaining in that compartment. The other compartment will continue to supply hydraulic fluid to the system without a leak. Click on the tank to see the effect. The hydraulic fluid quantity in each reservoir compartment is monitored by an associated low-level light on the hydraulic power panel, located on the flight deck overhead panel. When the level in a compartment decreases below 2.5 liters, the associated low-level light illuminates amber on the hydraulic power panel, the master caution lights flash, a single chime sounds, and the amber hydraulic low-level message is displayed on the engine and warning display, or EWD. In addition, the crossfeed valve closes automatically, if it was open. Two drain ports located on the bottom of the tank are used to drain fluid from the hydraulic reservoir. Two clogging indicators monitor the blue and green filters, in order to identify the presence of particles that have entered the system. These particles could potentially cause clogging. The indicators look like turkey pop-up timers and are visual indicators only. There are no cockpit warnings. They are located on the aft side of the reservoir. An overflow port relieves any excess fluid from the tank. This excess fluid may be due to overfilling or thermal expansion. After the hydraulic fluid travels through each system, it is returned to the hydraulic reservoir through two return lines, located on the top of the reservoir. We will now look at the green hydraulic system. The green hydraulic system is pressurized by an electric hydraulic pump. The pump is powered by the AC Wild Bus 2, and it has a normal pressure output of 3000 psi. The output of the green hydraulic pump is monitored by a pressure sensor, downstream of the pump output. When the green pump pressure drops below 1500 psi, an associated low-pressure light illuminates amber on the hydraulic power panel. In addition, the amber master caution lights flash, a single chime sounds, an amber hydraulic green low-pressure message is displayed on the EWD, and an amber low-pressure message is displayed on the AC Wild hydraulic page on the MFD. In addition, the system components powered by the affected system are displayed in amber on the AC Wild hydraulic page on the MFD. A temperature sensor is mounted in the return line of the green hydraulic pump. When the pump case drain line temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, a single chime sounds, an amber overheat message is displayed on the AC Wild hydraulic page on the MFD, and an amber hydraulic overheat message is displayed on the EWD. This indication may signify that bearing failure is impending for that pump. The corrective action for an illuminated blue or green system overheat light is to select the associated pump push button to off, and then select the crossfeed push button to on. Once the system has cooled back down, reselecting the pump push button to on is permissible. Downstream of the hydraulic pump, the hydraulic fluid travels through a one-way check valve. This check valve prevents the backflow of hydraulic pressure into the green system pump, in the event the crossfeed valve is open and the blue system is pressurized. The green system has an accumulator fitted in the line. The accumulator consists of a bottle that contains a charge of nitrogen. The nitrogen charge is separated from the hydraulic fluid by a piston. The accumulator acts like a shock absorber against pressure surges due to pump operation. The accumulator also assists the hydraulic pump when there is a high demand on the system. The green hydraulic system pressure is indicated on the AC wild hydraulic page on the MFD. The pressure indication is in thousands of psi. The sensor for the green system pressure indicator is downstream of the check valve. The blue hydraulic system is also pressurized by an electric hydraulic pump. The pump is powered by the AC Wild Bus 1, and it has a normal pressure output of 3000 psi. The output of the blue hydraulic pump is monitored by a pressure sensor, downstream of the pump output. When the green pump pressure drops below 1500 psi, an associated low-pressure light illuminates amber on the hydraulic power panel. In addition, the amber master caution lights flash, a single chime sounds, an amber hydraulic blue low-pressure message is displayed on the EWD, and an amber low-pressure message is displayed on the AC Wild hydraulic page on the MFD. In addition, the system components powered by the affected system are displayed in amber on the AC Wild hydraulic page on the MFD. Remember, the corrective action for an illuminated blue or green system overheat light is to select the associated pump push button to off, and then select the cross-feed push button to on. Once the system has cooled back down, reselecting the pump push button to on is permissible. A temperature sensor is mounted in the return line of the blue hydraulic pump. When the temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, a single chime sounds, an amber overheat message is displayed on the AC Wild hydraulic page on the MFD, and an amber hydraulic overheat message is displayed on the EWD. The blue system incorporates an auxiliary pump. This pump draws fluid from the blue system hydraulic compartment. This pump is used on the ground to boost blue system pressure when neither engine is running, and none of the main hydraulic pumps are operating. Once the blue system pressure is boosted, the parking brake may be reset, or the prop brake can be engaged. The auxiliary pump also develops 3000 psi of pressure. However, this pump has a reduced flow rate. The blue system auxiliary pump is powered by either the DC bus 2 or the hot main battery bus. Normally, DC bus 2 is the power source for the auxiliary pump. If DC bus 2 is not powered, the auxiliary pump is powered by the hot main battery bus, if the hydraulic auxiliary pump push button is depressed. This push button is located on the forward, left-hand side of the center pedestal. Once depressed, the auxiliary hydraulic pump will run for 30 seconds. The auxiliary pump will operate as long as the hydraulic auxiliary pump push button is depressed. You should note that you can use this push button to operate the auxiliary pump, even if no power is on the aircraft and the battery switch is off. If at least one engine is running, the auxiliary pump is powered by DC bus 2. The pump will operate as soon as one engine is running provided the gear handle is down. The hydraulic auxiliary pump push button on the hydraulic power panel is depressed. The propeller brake is not engaged. And the blue hydraulic pump output pressure is below 1500 psi. The auxiliary pump will cease to operate if any of the enabling conditions is removed. If the propeller brake is engaged when the auxiliary pump is operating, the auxiliary pump will continue running for 15 seconds after the propeller brake is engaged. If the auxiliary pump started to operate because the blue main pump output pressure dropped below 1,500 psi, the auxiliary pump will stop when the main pump pressure rises above 2,100 psi. The output of the blue auxiliary hydraulic pump is monitored by a pressure sensor downstream of the pump output. When the blue auxiliary pump pressure drops below 1,500 psi, the auxiliary pump low pressure light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, a single chime sounds, an amber hydraulic auxiliary low pressure message is displayed on the EWD, and the amber auxiliary low pressure label is displayed on the AC wild hydraulic page on the MFD. A temperature sensor is mounted in the return line of the blue auxiliary hydraulic pump. When the temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, a single chime sounds, an amber hydraulic auxiliary overheat message is displayed on the AC wild hydraulic page on the MFD, and an amber hydraulic overheat message is displayed on the EWD. The auxiliary pump supplies hydraulic pressure to the same line that is supplied by the blue hydraulic pump. One-way check valves prevent the backflow of hydraulic fluid into either pump. The blue system has an accumulator fitted in the line. The accumulator is exactly the same as the green system accumulator, and it performs the same function. The blue and green hydraulic systems are interconnected through a crossfeed valve. If one pump fails, pressure to the affected hydraulic system can be restored by opening the crossfeed valve. The crossfeed valve is controlled by the crossfeed push button on the hydraulic power panel. Click on the crossfeed push button to open the crossfeed valve. Once the crossfeed valve is opened, it will automatically close if the fluid quantity in either hydraulic reservoir compartment drops below 2.5 liters. This will prohibit adding fluid to a system that could possibly be losing fluid, and prevents the other system from losing fluid and entering a low-level condition. If you recall, a fluid level below 2.5 liters will cause the corresponding low-level light to illuminate on the hydraulic power panel. If either low-level light is illuminated, the crossfeed push button is inhibited, and you will not be able to open the hydraulic crossfeed valve. This situation is indicated on the AC wild hydraulic page on the MFD. The crossfeed icon has a white inhibit label. The status of the crossfeed valve is displayed on the AC wild hydraulic page on the MFD. When the valve is open, a green line will connect the two systems. Otherwise, only a closed crossfeed valve is depicted. This screen depicts the various icons for the crossfeed valve. The crossfeed valve is electrically controlled. It is powered by the DC standby bus. The crossfeed valve will automatically close if power is removed from the valve. The emergency and parking brakes have their own accumulator. The accumulator is located after a one-way check valve. Unlike the main hydraulic system accumulators, this accumulator stores enough pressure to allow for 6 applications of the parking brake. The pressure of this accumulator can be read on the pressure indicator, located on the left maintenance panel. In addition, the emergency and parking brake accumulator pressure is displayed on the AC wild hydraulic page on the MFD. As you saw earlier, the hydraulic system is controlled by the hydraulic power panel located on the flight deck overhead panel. The systems supplied by each hydraulic system are listed under each pump push button. A simplified schematic of the hydraulic system is etched in the faceplate of the hydraulic power panel. The main hydraulic pumps are controlled by the associated pump push buttons. The push button and alert lights of the blue system push button are powered by the DC emergency bus. The push button of the green system is powered by DC essential bus. The alert lights of the green system push button are powered by the DC emergency bus. Each main hydraulic pump is controlled by its associated push button. A pump is energized when the associated pump push button is depressed, or in position. A pump is deactivated by placing its associated pump push button in the released, or out position. The white off light illuminates when the push button is released out. On the AC Wild hydraulic page, a pump that is running is indicated by a green square with a vertical line. When a pump is selected off, the vertical line is replaced with the white off label. This screen depicts the various indications for the hydraulic pumps. The auxiliary pump is displayed in a similar manner. The main difference is that when the auxiliary pump is selected on, but is not running, a standby label is shown within the auxiliary hydraulic icon. This screen depicts the various auxiliary pump icons. Hydraulic system pressure is displayed at the top of the AC Wild hydraulic page. The indication is green when the associated pump output pressure is greater than 1,500 psi. Otherwise, it is displayed in amber. As mentioned previously, the components powered by each system are also displayed in amber if the associated pump output pressure is below 1,500 psi. This concludes the hydraulic system module.